Okay, so let's get into the same origin policy, what it is, and how does it work in the web essentially to create the web security model. So let's think about when we're in the web, okay, and we're talking about web security, let's think about what should be allowed, right? So when we're thinking normally, okay, as we're navigating websites and things like that, let's go over a few scenarios and let's see if intuitive we can say, hey, you know what? I think this is something that should be allowed in the web or it shouldn't be allowed in the web, right? So let's go through the first one. Should site A be able to link to site B? Well, yeah, I would say yes, because this is the main way that the web works, right? The web, it's made up of documents, and those documents have links that link to other resources, right? So again, I don't think there's anything wrong with this, and this is essentially the way the whole web works, right? So the reason why it's actually called the web is because it's this interconnected link structures that connect to any other resource, right? So pretty much anything on the web can be a link and can access and can link to any other place on the web itself, right? So second thing, should site A be able to embed site B? Again, maybe there's good reasons for why someone might want to embed something on their site that doesn't belong to them. So if you think of YouTube, for example, you can embed a YouTube video on any website, right? So they give you an embed video, and that's actually a very or any other video hosting website that maybe you host it on their service, but then you want to show it within your own website context. Again, totally valid reason for having this functionality be part of the web. Another scenario, which is, should site A be able to embed site B and modify its contents, right? So this is kind of what we were just looking at in the previous example, where not just did we embed a website within another website, so not just did we embed one frame within another frame, we were also able to change the contents of it. So whenever someone types something in one, it kind of reflected on the other one immediately, right? So that's that again, that kind of gets us in like hot water, because that, there could be some reason why, like that's definitely a vector which someone can attack. But again, there could be totally you know valid reasons for having that functionality be available. For example, if we wanted to create an API in real time, and we wanted to reflect to anyone who subscribed to that endpoint the changes as they happen in real time, right? That's completely valid, and we see that all the time with real time services. So again, it's just something that we have to know and think about. The next one, should site A be able to submit a form to site B? Again, we've seen this in the past in previous lessons, that whether it should or not, it's definitely possible, right? So we definitely know that this is part of from the beginning of the web. This was implemented, and we saw how we can kind of attack this by with session cookies, and session hijacking can actually happen because of this feature. But again, it's been part of the web since the beginning, and I don't think it's going anywhere. So yeah, this is something that happens all the time. And again, there are completely valid reasons why someone might want to automate a certain process on the client side, and for that to happen, we're going to submit a form on the user's behalf. So again, there's completely different valid reasons for this functionality to also exist on the web. The next one, should site A be able to embed images from site B? Yeah, absolutely, right? We can actually, let's say that we want to host our images on a CDN. That way they can be cached, and then we don't have to use up our own bandwidth, but we can still serve our own images. And that happens all the time for big websites that have a lot of traffic, and we want to make it as efficient as possible and optimize that bandwidth. So again, embedding images, and even the next one, which is embedding scripts. If you've ever embedded jQuery or any other scripts into your own websites as you're developing, this is again just part of how the web works. And as far as we're concerned, we I don't think it's going anywhere, because it's again, it's fundamental to how we build websites. And as the web becomes more and more powerful, I think this is just something that's going to become even more of a prominent feature, and something that we can really be more useful. So again, I don't think this is going anywhere, but again, this is again part of the stuff that we have to be thinking about when we're thinking about same origin policy, right? Because these are all parts of the web where we're accessing resources that are not necessarily part of our own domain, but that we need in order to serve our users endpoint. But again, because of this, you can kind of see how all these things kind of open us up to certain risk and vulnerabilities on the client side. So when we're talking about same origin policy, if you remember one thing, remember this. This is the fundamental security model of the web, right? And it goes something like this, right? So this is kind of how the spec is laid out. Two pages from different sources should not be allowed to interfere with each other. Okay, so if two pages are in different domains, then essentially someone should not be allowed to mess with one other domain. But again, we have seen how with iframes or with cookies and things like that, we can get around some of this stuff. But this is the essential security policy that the web is trying to enforce when they created the spec, essentially. So if we think of the web as an operating system, it really will help us out in understanding how some of these security features and came to be, and then some of the stuff that we can do to mitigate it. So what is an origin? That's the first thing we need to understand. So an origin, if we're thinking of the web as an operating system, it's very analogous to an OS process. So when you open up an application on your computer, right, that spins up a new process on your computer. And the web, in many ways, whenever you spin up a new tab or a new website, that's kind of like a new process. And again, on the web, it's called task. And we went over this in some of the first lessons. But it's very similar to a process on the computer itself. The web browser, you can think of it as analogous to an OS kernel, right? So this is where pretty much we are going to load and have access to APIs that are part of the browser or to the web itself, right? Or to the origin, right? So if you are on, let's say you open up iTunes or any music player on your computer, then that has access to the files where your music is stored, right? Or if you're opening up some other application on your computer, then that has access to the memory allocation on your device, right? So again, the web browser is pretty analogous to this. Once we open one up, it's analogous to the kernel, and through the kernel, we can we have access to different APIs and different services of the web itself, right? So sites rely on the web browsers to enforce all these systems and security rules, right? So we're just like the kernel, and how a computer, when if some malware gets installed on your kernel, then that's that kind of screws everything up, because then your computer is compromised. It's the same thing on the browser, because we are relying on the browser in this case to act as the operating system and to enforce the security rules that the web that the spec is supposed to enforce, right? But again, the browser at the beginning was not intended to be this way, but it has evolved to this to kind of this powerful application that everyone uses. And as we're trying to move applications more away from certain marketplaces to be broader accessible, then we turn to the web, and the web again wasn't made for this thing. So just like an OS, if there's a bug in the browser itself, then there are these rules that go out the window, right? So we're gonna go over the rules that are the same origin rules. But again, if there's an issue with the browser, or the browser gets compromised, right, or someone's able to execute some code on the web, on the browser, then kind of these rules go out the window. So what's the basic rule? Again, the basic rule is this: given two separate JavaScript executions, right? So two different tabs, two different domains. One should be able to access the other only if the protocols, the host names, and the port numbers associated with their host documents match exactly, right? So, and this protocol host port tuple is called an origin. So let me just show you an example of what we mean by this. This right here, right? The protocol, the host, and the port. So this whole thing, and mostly what we see on the web are these part. We usually don't see the port number, although it's there implicitly. For most websites, it's port 80. Once we have this thing, this is kind of only so if this website is trying to access some other resource, what needs to match in order for that resource to go through, or for that request to go through and not get blocked by CORS or by the same origin policy, then the HTTPS, right? So if you're making a request from HTTPS and you're requesting something over HTTP, then that's going to get blocked. If it's trying to access something from a different website, so a different domain essentially, host, then that's going to get blocked. And if it's on a different port as well, then that's going to get blocked. So all these things have to match for all those requests to go through, right? If you're trying to make a request from within JavaScript. And just to show that this is not very hard to, if we wanted to create our own function that checked if we, just like the same origin policy. So if we wanted to execute this ourselves and actually create our own function, it's not really that difficult, right? All we have to check is the URL protocol, right? The host name and then the port. And if all those things do match, then what we say is, yeah, this website's allowed to request a resource from the resource they're trying to request, then it's allowed, and we should return it at that point, right? So we should return a response code of 200, and everything is fine. If one of these things do not match, then we know that we have an issue, and then someone else is trying to access a resource. So this could be something that's behind a paywall or behind some type of authentication, and then that way we know that then they should not have access to this resource, right? Okay, now let's go over the attack that we saw at the beginning of the lesson, and let's see how we implemented that attack, right? So the idea is, can we send messages from a parent page to a child iframe, or vice versa, right? So we need a way to get around the same origin policy to allow two different origins to communicate. Now that we know that the same origin policy is not going to allow us to do this, we need a way, because again, there are very valid reasons for why we might want to communicate. Again, and one that comes to mind automatically for I think all of us will be an API, right? How do we access an API that's on a different origin and communicate with that API if we need some data or some resource that's not necessarily something that we have ourselves, right? So this could be weather data, and you're trying to access the weather API or anything like that, right? So first, we're going to talk about how we're going to execute this attack, right? So what are the vulnerabilities in this, and then we're going to go ahead and talk about some of the defenses for this thing. So the way the attack was executed is actually very simple. Okay, so I'm just going to show you the child code. So I'm going to set up again two servers to kind of showcase the these are two different, okay? Remember, two different origins, and the origins are the protocol, the host, and the port, okay? So I'm gonna, one of them, the child is gonna be on port 5000, and then the parent is gonna be on port 4000, okay? So the first thing we're gonna do is we're gonna do this. On the child side, okay, which is the page that's going to be iframed, right? So this is gonna be kind of the page that's gonna get attacked. We're gonna get, we created a div, then we get a handle to that div, and then we're going to set an interval, and that interval, what it's going to do is it's going to accept through this window hash, and for a long time this is the way that we were able to get around the origin communication. So what we did is, if you remember when I talked at the beginning about the way URLs are formed, we can add to the URL at the end a little hash, and that actually does not refresh the page. What it does is it's kind of like an anchor tag, and it takes you to that page on the tag. So what we can do is we can use that part of the URL as a communication mechanism. And then what we're going to do on the parent side, it's we're going to create an input, right? So we have an input over here, okay? So we're going to get a handle to that, and then we're also going to get a handle to the iframe. So we're going to iframe that child page in here, okay? And remember, that's hosted on port 5000. So now that we have access to the input and the iframe, now that we have a handle to those, over here what we're going to do is we're going to add an event listener. And anytime something changes in the input, what we want to do is we want to change that iframe source. So remember, we can change also on because we're embedding this iframe, then we can change the source of it, which again, this is why the attack works, and how we can get across cross origin, like across the origin domain policy that we shouldn't be able to do because these two pages are actually on different origins. But anyways, this is what we're gonna do. So we're going to include the regular URL. So up to this point, everything is the same. But then what we're gonna do is we're going to add a hash, okay, and then we're going to encode that URL component, the input value. We're gonna encode it, and then we're gonna pass it as the source. And then over here in the child component, if you remember, we have that interval, so we're just gonna poll, right? So we're just going to, as soon as, like every millisecond, we're gonna poll and see if that hash has changed. And if it's changed, then we're gonna change the context of that div to reflect the change that happened. So again, so this is the first attack we're going to do, and then we're going to change the attack a little bit to show you another method that we can get past this the same origin policy. So I'm going to go ahead to the browser and I'm going to refresh this, and then let me just make sure that on the attacker server, yeah, so we've actually commented this the defense out as well. So at this point, and again, this a lot of, remember, there's a lot of forms on the web, and a lot of you know, if you're not actually being proactive about securing your forms, and all these things can happen. And again, it could be as simple as you know, just again a little simple message like we're seeing over here that's being passed around, and it could be just some API data that's exactly what you want, but it can also be some credentials, some user credentials that get passed around, and again, it's a huge vulnerability if it does happen to be credentials, because at that point then someone can not just take over the identity of the user like we saw in session hijacking, then essentially they can own the whole account, right? They can own the whole you know, that whole website, and at that point they can do whatever they want. So but anyways, the way this is working, just so we can see that we're communicating across origins, it's through the hash. So if you look over here, I'm going to show you in the body itself that it's pretty hacky, okay? I'll admit it, but this is the way it was done for a long time. But so I'm going to put it over here, let's say you know, cross yeah, cross origin policy hacked. So as you can see over here, we're seeing that after the hash, everything is being reflected on the URL, but it's not being refreshed as we would if we were to change some of the path. So since we're essentially not changing the path, all we're doing is we're using this hash as a communication mechanism. Then we can see how we can hack the origin policy. Okay, so let's go back to the child and let's change it. So eventually, the spec got around, and the committee got around to changing the spec. And then what they did is, because again, as APIs became more prevalent and people wanted a way to access different resources or communicate across different origins, we needed a better way that was less vulnerable, right? And had an actual spec built out for it. So what we're gonna do is we're gonna change on the child side. Now we're gonna add an event listener, okay, and we're gonna listen to a message event. So this is when the post. What we're gonna do is we're gonna take advantage of the post message API. Okay, so that's what I'm gonna show you now. And the post message API, what it allowed us to do is it allowed us to do exactly this with sites that are cooperating. So if you are building an API and you want to cooperate with people that have access to this API, and essentially, you know, communicate across origins, then this one way that's a lot more secure, and there's actually defenses against this. Whereas this way that we were doing before, you know, if this is the way you're doing things, or if a website is doing things this way, then it becomes very vulnerable to cross origin policy attacks. So we're gonna attach a message handler, a message listener to the window event. And then what we're going to do is, if event.origin does not equal localhost 4000, so at this point we're saying, hey, the only people that we want to have access to this is if it's coming from port 4000. And at this stage, you can pretty much set any origin you want. So you can change the host, the protocol, anything at this point. Because again, this is something that you're actually built. This is a spec that's actually built into the browsers nowadays. And then if it's not from somewhere trusted, then we're going to do an early return. Okay, and we're going to say, hey, you know what? We're not going to actually share data with them. But if it is from localhost 4000, then what we're going to do is we're going to say div.text content, make it the event data. So we're going to make it something very similar to what we were doing up here. But at this point, you know, you can see that we don't have to use the hash or any of this hacky, sketchy method, and we can use the post message API, which is much nicer. So on the parent frame, all we have to change is this line of code, and then once we have again that handled to the iframe, we're going to do content window, and then the post message API. So we're going to say, hey, from that iMessage, as we've seen changes events being inputted, what we want to do is we want to get the input event. Yeah. So whenever something changes in the input, okay, what we're going to do is we're going to post it. Okay. So we're going to attach it to the iframe through the post message API. Okay. And then remember, the child is using the add event listener, and they're listening to the post message. So anything that comes in through the post message, and specifically from the 4000 port, then they're gonna say, yeah, that's acceptable, and that's again, that's where this website is gonna be hosted on port 4000. So, and then we're gonna include with it the input.value, right? So just send the value. Again, at this point, we don't have to encode URI component, because then the browser is gonna take care of sanitizing this for us, and we're gonna say the only website that we want this to actually go to is to port 5000, right? So if someone else maybe embeds an iframe and tries to change this, they won't be able to, right? So if they try to change a message, because the child is saying that they want to accept only messages from port 4000, and then the parent is saying that they want to send only messages to port 5000. So they're essentially saying, hey, we want to cooperate with each other, and we know this is cross cross origin domains, but in any case, because we're using the post message API, then it makes it kind of safe, a safe API to use. So this form of communication across origins. So I'm gonna go ahead and let me just restart the servers, okay? And then we're going to what we should see is essentially the same thing, but I'm gonna show you how now with this method, then the users, we can achieve the same thing. So if we wanted to implement this, for example, for an API, this would be the right way to do it. And now we're saying cross origin request. But as we can see over here, the URL, okay, is not changing. So, and everything is going through the post message API at this point, which is again a lot safer, because this has actually been implemented in the spec, and it's and safe to use. Okay, so there you go. That's one of the defense against not just a defense, but now that we have gone over the attack, and you can see how, different, if someone embeds a website within another frame, and then there's an input field, then someone can use this post message API or the other method we're using to essentially attack that vector. Now, if you want to completely stop this from happening, then what you need to do is not if what you want to make sure is that your website does not get iframed, and because once it gets iframed, then it opens us up to a whole bunch of attacks that we can't stop. For example, someone changing the contents of the website, someone injecting JavaScript at that point, and it just becomes very, very difficult to stop. Then what we need is a new header, and the header is called xframe options. And then what you want to set it to is deny. Okay, so once we do that and we refresh this page, we can see that that page now is not being able to be iframed. And although we can type in here whatever we want, so even if someone was trying to iframe us and get the data that we were typing in whichever inputs, then at that point it won't matter anyways, because they won't be able to iframe us, and no data will be leaked into the parent or the child. So again, that's the header for that. It's xframe options, and then just set it to deny. And again, so if you're on the server, you can set this yourself, and then you're pretty much set as far as that attack is concerned. Okay, so there you go. That's so that's that's one way. Okay, if we wanted to communicate across origins, but because of the way that the same origin policy is set up, we know we can't do that, right? So we need a way to get around. One way to get around is through the post message API. That's the way that you should be using. So don't use the other API, because again, that opens us up to a lot of vector attacks. So we want to use the one that's safer, and that's the post message API. Which what it does is it does a secure cross-origin communication between two cooperating origins. So as we said, it's very important to put who you want to accept messages from and who you want to send messages from. Okay, so you can't forget that part. And then what it allows us to do is it allows us to send strings and arbitrarily complicated data across origins. Okay, so because this is actually implemented in the spec itself and it's not some hack, we can actually send a lot more information through this channel, and we can even send video information and a lot more complex objects. So not just simple strings. Okay. Now, another thing I want to point out here is I want us to remember that cookies do not obey the same origin policy, okay? And we saw that when we were doing the session hacking attack, okay? And the simple reason for this is that cookies were created before the same origin policy, so they have a different security model. Now, after cookies and they were implemented in '94, and I think the same origin policy was implemented in '95. What happened was that people were catching on, and they were like, "Wow, this cookies really open us up to a lot of attacks." And if we don't have a secure way that the websites can request resources from each other, then that's then the web was going to be kind of screwed. So then that's why the same origin policy came into being. So cookies are, again, more specific than same origin policy, and again, at the same time, they can be less specific. So because cookies have, and again, we saw that with you can say your cookies to the same site. And then because of that, then it can be read from JavaScript, or it can be they won't be included within the request headers themselves. So that's one way to stop the passing around information across different domains. But now that we have same origin policy, and you can see how that can be bypassed, then what we essentially need to configure this and make it safer, it's that header, which is X-frame options, and then just set that to deny, okay? And then that will allow us to abide by the same origin policies, and then we can relax it whenever we need to. So we can deny essentially any bad actors from requesting resources from our servers if we don't want to send those resources, and at the same time, we have the capability to relax those policies and send information to anyone that we want to. So again, we have, I think, the best of both worlds when we do it that way, right? So one of the caveats that I want to talk about, and one of the attacks that you should be aware of, because of these methods of the same origin policy, besides the one that we talked about, I want to at least walk you through a few other ones that you might have seen out in the wild, and again, because of the defenses that we talked about in this lesson, then you'll be able to be secure yourself from it. So can we prevent a site from embedding our site? As we saw, yes, we can, right? Now, what might be the reason for this? Like, why would you want a website to not be embedded into your site? Besides, some of the stuff that we've seen already, well, clickjacking is something that's very dangerous. And because cookies are, because let's say someone can embed your site within their website, right? So over here in this example, we have this example.com, and it's clickbait, right? So I see it on TV, and then they want the person at this point to click on this button, right? But what they're not seeing is that this eBay website, it's embedded within that frame, but it's in this example, just so that you can see, they've set the opacity to 10, but essentially you can pretty much set the opacity to 0, right? So when the person clicks that free button, they will actually not be clicking on the free button themselves. They will be clicking on the page that's on top of that frame that's on top, which will be the eBay site. And if they're logged into eBay, right? So if that session is still active and they buy that item, that's called the clickjacking attack, okay? Which is different from session hacking. But again, it's because of the same origin policy. And if someone embeds that website, then, and the way cookies are set up, right? Then at that point, 3 things have happened. They've hijacked the session. They've clickjacked they've jacked the click. So essentially, they've crossed over the origin as well. So that's a very dangerous attack. And again, this happens all the time, right? Especially with older browsers that are not aware of this stuff, or they don't have the same security policies as the same origin policy, or or against if you're a web developer and you're not kind of defending against these things can happen to your users, and they can be very dangerous. So clickjacking, again, that might be one of the reasons why you might not want someone to embed your website. So again, it's very valid. But again, if you're like setting up an API, then that might be something that you want. And again, you just have to make that decision for yourself, depending on the needs that you have and the needs that your users have and your website have. So can we prevent a site from, again, embedding our website? Yes, we can. And I show you the header for that. Another thing that I want to draw your attention to is this paper called Busting Frame Busting. It was published by Stanford professors, I think like 10 years ago, and there's the URL here for you to access it. So essentially, what they were able to do is they and in the paper it goes over a lot of examples of how someone was able to embed one website. An attacker was able to embed a victim's website within their attacker, and then they're able to perform all sorts of attack and then cross that same origin policy. So they're able to bypass the same origin policy and really create a lot of attack vectors that a victim can essentially be a victim to, that another website can essentially be a victim to. So let me just walk you through some of the options for the HTTP header for the X-frame options. So by default, this is not specified, right? So this is something that you actually have to opt into. Okay, so this is not something that's actually default in the browsers. So if you're not aware of this, then again, you're kind of at the mercy of someone being able to embed your website and then doing whatever they want at that point. Then the next option, which is the option I suggest that you set if you don't want it to be iframed, is the deny option, which is the one that we went over in this lesson. So what this pretty much does is it doesn't allow the page to be iframed. And then the other option, it's let's say you do want the page to be iframed, let's say, but that you only want it by the same origin. So only by other sites that live within the same origin, right? So that have the same protocol, host, and port. So only by those path do you want it to be able to be iframeable. Then set the same origin, set the header to same origin, and then at that point, then that will at least if you do need it to be frameable, but you don't want it to be susceptible to some of these attacks by anybody, then just set it to same origin.